So today we will start chemical bonding, which is one of the most important topic in chemistry. And before starting this concept, we will need to clear regarding the octet stability or octet field of electronic configuration. If the octet electronic configuration is present in its particular atomic electronic state, in the atomic elemental state, so the atoms of that particular element will be stable condition, will be in the stable condition. If the atom is not in its octet state, then it will not be in stable state. So, to have the octet field of electronic configuration, to get the stability of that particular species, they needs to lose electron or accept electron. Suppose sodium in its atomic state, that is in its normal electronic configuration is 1s2, 2s2, 2s6, 3s1. So the extra electron, one electron present in 3s1 orbital, which needs to be released by sodium to get the octet electronic configuration, that is 1s2, 2s2, 2p6. So by departing or by losing one electron, sodium will form sodium plus to have the octet field of electronic configuration, which is much more stable than sodium. Similarly, gaining of electron to have the octet electronic configuration also can be possible by the atoms. Suppose an electronegative element like Cl or chlorine have the atomic number of 17 and the electronic configuration of 1s2, 2s2, 2p6, 3s2, 3p5. So this is the electronic configuration of chlorine. So here the outer electronic configuration, that is the valence shell having the 7 electrons. Valence shell having the 7 electrons. So to have the octet field of electronic configuration, Cl will have one extra electron. Cl will need one extra electron to get stability, to gain stability. So here Cl will form after accepting one electron to form Cl minus, and thereby it will form Cl minus, and the electronic configuration it will attain, that is 1s2, 2s2, 2p6, 3s2, 3p6. So that is of 8 electron in the valence shell present, and that is octet field of electronic configuration. Octet electronic configuration. Octet electronic configuration. So in that particular case, 8 electron is there, and also in case of sodium plus, also the outer electronic configuration is having the 8 electrons. So the 8 electrons are present both, that means the valence shell electronic configuration will be of 8 in both sodium plus and chloride minus, and that becomes much more stable than sodium and chlorine. So whenever in the medium sodium plus and Cl minus will be in the closer proximity, they will have a minimum amount of force in between them, that is called the electrostatic force of interaction. That is called the electrostatic force of interaction. Na plus and Cl minus going to be formed a bond that is called electrovalent bond. Electrovalent bond by the electrostatic force of interaction. By the electrostatic force of interaction. Electrostatic force of interaction. So in this regard, we need to say something regarding the force of attraction, which is present in sodium plus and Cl minus. That is the Coulombic force of interaction developed between Na plus and Cl minus whenever presenting certain distance. So the Coulombic force, that is the law of Coulomb, is governed by the equation, that is F is equals to K into Q1 Q2 by R square. So that is the Coulomb's force of interaction law, by which Na is Cl compound compound, or ionic compound. As the ions are present there before the formation of the compound, so that is ionic compound. So one of the type and a bond is thereby formed between Na and Cl. That is Na and Cl, the bond is formed. That type of bond is called ionic bond. That type of bond is called ionic bond. There are another example of ionic bond having the compound, that is NaCl2. Example, CaCl2. Ionic compounds are there. So the type of bond which is present, this kind of compound are ionic bond. And next important concept is covalent bond. That is nothing about like that. The transfer of electron. Here the transfer of electron is there. Like in case of ionic bond, what is present there, like sodium will have to release one electron, and that electron will be accepted by Cl to form Cl minus. So that is the case of transferring electron. That is a case of transferring electron. That is the case of transfer of electrons. Okay. So here one part will donate electron, one part will accept electron in case of ionic compound or electrovalent compound which is observed. But in case of covalent bond, another type of concept can be raised there. That is the mutual sharing of electrons will be there. That is both of the atom present in a molecule will mutually share the electron and have the octet electronic configuration. That is the basic thing in covalent compound or covalent molecule. So just for an example, for NH3 or H2. H2 is a covalent compound, HCl is a covalent compound, NH3 is a covalent compound. So one of the compound we will going to discuss. One of the important compound, that is H2O or NH3 or HCl. Suppose NH3 for the explanation of covalent bond, we will discuss regarding NH3. Just for NH3 there is a mutual sharing of electron. To know regarding the stability of each of the atom present in the compound, we will say that is in one mole of NH3, like one NH3 molecule, we can say that nitrogen is present, hydrogen is present. So the outer electronic configuration of nitrogen is 1:2:2p3, and for hydrogen that is 1:1. So here hydrogen and helium will have to form doublet instead of octet. So if the outer electronic configuration of hydrogen and helium is of 2 electrons, then it will be stable. So in case of hydrogen and helium, that will be doublet completion will be stable. Doublet completion of hydrogen and helium, so that particular element will be stable. For nitrogen and for hydrogen, there has the instability, so they need to be stable by sharing of electron in between themselves. Like for nitrogen, the outer electronic configuration is 2:2p3, so the valence electron is here 5, substitution of octet. Here also octet to be followed. That means octet for nitrogen and doublet for hydrogen needs to be followed to get the stability. To become stable state, to have a stable state, NH2 will have that particular electronic configuration. So mutual sharing will be there. So what is the mutual sharing? How the mutual sharing have been done is given by this diagram. So here 2s2 2p3 is there. So total 5 valence electron is there. 1, 2, 3, 4, 5. So here no transfer of electron is there. Only the sharing of electron will be there. Only the sharing of electron will be there. So thus the mutual sharing of 3 hydrogen will be there. Thus form the covalent bond. Thus form the covalent bond by mutual sharing. Hydrogen will have the 2 electron with a mutual sharing of 1 electron from nitrogen, and from its self electron they will form outer electronic configuration doublet, and nitrogen will have the octet electronic configuration by sharing of 3 electron taken from hydrogen. That is, the sharing of electron is there, no transfer of electron will be there. So here 2 electron is present in a lonely manner, that are called lone pair of electron or non-bonded electron. Lone pair of, that is lone pair of electrons present here. So the compound formed by the sharing of electron, that is called covalent compound. And this type of compound will be governed by the sharing of electron. Sharing of electrons. So that's it for today. We will go to the next explanation in the next video. Thank you everyone.